Hello everybody. Today we are going to be talking about Chapter 6, Lesson 3. Again, we're talking about more transformations. Today, specifically, we're going to be talking about rotations. So, again, when we talked about a translation, we talked about how that was a slide of the figure. We talked about a reflection, how that was a flip. Okay, and rotation, that's going to be a turn. So I turn the figure. So a rotation is a transformation in which a figure is rotated or turned about a fixed point. Okay, whatever that point is called the center of rotation. So what am I turning around? That is the center of rotation. A rotation does not change the size or shape of the figure. So again, the shape and the size all stay the same. We're just moving the figure around, and we're turning it around a certain point called the center of rotation. So again, just like translation and reflection, the pre-image, our starting point, and the image, our ending point, are congruent, which means they are exactly the same. So if we take a look here at an example, okay, it says triangle LMN has those vertices, and it represents a desk in Jackson's bedroom. He wants to rotate the desk counterclockwise 180 degrees about the vertex L, graph the figure and its image, then graph the coordinates of the vertices. Okay, so I'm going to start by graphing my pre-image. L is at 5, 4, 2, 3, 4, 5, 1, 2, 3, 4. M is at 5, 7. Let's see, 5, 5, 6, 7. And N is at 8, 7. 7 all the way up there. L, M, N. So this is our triangle. It is a right triangle. So now it asks us to rotate it counterclockwise 180 degrees about vertex L. So one thing we need to understand is our basic amount of degrees. Okay? So, in general, when we talk about angles, we work around the coordinate plane in a counterclockwise manner. Okay? Clockwise is the way the clock turns. That would be this way. Counterclockwise is this way. So if we start here, every time we hit an axis, that is 90 degrees. So this first one here is 90 degrees. One axis. We go through that one to the second one, that would be 180 degrees. Okay? Two axes all the way around. 3 would then be 270. And of course we all know, let me extend this out a little bit, all the way around in a circle, coming right back to where we started, was 360 degrees. So this might be a figure, if I were making a note card, I would definitely put that on my note card. So I remember about how far a 90 degree rotation, 180, 270, and 360. Okay, it's 1/4, half, 3/4, full turn. All right. So now, if I want to rotate the figure in 180 degrees clockwise about vertex L. So again, I'm sorry, counterclockwise. So I'm going to moving to the left 180 degrees. So 180 degrees is a quarter turn, a half of a turn. Okay? So what I want to think about is putting my pencil or putting my finger right on my center of origin or my center of rotation. So if that's L, I'm going to rotate right around that figure. Okay, so if you can visualize this, and this is where it gets tough, that would be about a 90 degree rotation from the start. This would be about a 180 degree rotation. The difficult part is we need to leave that one there. So if you think about it, I'm taking this, and here's L, here's this straight line. If I want to rotate that 180 degrees down, that comes right down here. Okay, so you can visualize. If it were only 90, it would be there. Okay, 180, if it was 270, it'd be there. At 360, it'd be right where it started. So the difficult part about rotations, especially when we talk about turning it about a vertex, is you really have to visualize it. Okay, so I know it can be difficult to start, but the more you do it, the better you're going to get at it. So if I'm moving to the left 180 degrees, that means I'm going to take this line and I'm going to move it 180 degrees down here. So L and L prime are going to be in the exact same spot because we're rotating around that point. It's not moving anywhere. M prime now, if you can visualize this triangle being rotated down, it was 1, 2, 3 units above that. Now it's going to be 1, 2, 3 units below. Okay, so we'll call that M prime. And now this point over here, we're rotating it down so that N is going to be out here on this side. Okay, it's going to be out to this side. That point off to the side because we're just taking it and swinging it down. So then N was 1, 2, 3 units away from N. So I move 1, 2, 3 units away from M to get N prime. Okay, hopefully you can read those. So then my image of my triangle would be right here, L prime, M prime, N prime. So I rotated that figure down 180 degrees counterclockwise. Again, it's something you just really have to visualize, especially when we're moving about a vertex. So go ahead and try A on your own. I'll be back in a minute to go through it with you. Okay, you should have tried A on your own. Let's go through it. So if I'm at -7, 4, let's see if I got enough room here. 1, 2, 3, 4, 5, 6, 7. I do. 1, 2, 3, 4. Right there. That is point A. -7, 1. That would be B. -2, 1 is C. And D is -2, 4. So here we have a rectangle. It looks like this represents his bed. So we connect our dots to complete the figure. So again, we're going to have a rotation about a vertex. So this is something we're going to have to visualize. Okay, so we want a rotation of 90 degrees clockwise about vertex C. So I'm going to think about putting my pencil or my finger right on vertex C, and that's not going to move. And I'm going to rotate this thing 90 degrees that way. So if you can visualize that, what we're going to end up with is this entire thing moving this way and just kind of tipping on its end. Okay, so 90 degrees is only a quarter turn. So again, here's my center of rotation. So I think about this line here. If I rotate that 90 degrees clockwise, it's going to end up right down here. So now I need to think about this line segment CD in my image is going to be down here. Okay, so D is 3 units away from C, so C prime, and D prime would be 3 units away. 1, 2, 3, right here. D prime. Now from D, A is 1, 2, 3, 4, 5 units above. So 1, 2, 3, 4, 5. That's going to be A prime. And by now you can probably fill in this backside vertex. It is 3 units away from A. 1, 2, 3. Hold on. 1, 2, 3 right there. That's going to be B prime. So if I fill in my lines, you can see I've rotated this figure 90 degrees clockwise, so it's now standing up on its end. Obviously, not when we're talking about the bed. The bed isn't standing up on its end. The bed has rotated within the room. So there you go. 90 degrees clockwise rotation from here. We turned it around C so that it's right there. And that's how that goes. So now, the next type of rotations, I think, are a little bit easier because you don't have to visualize them. We have transformation notation and rules that we can actually use to find our answer. So it's a little bit more concrete, not nearly as abstract. So a rotation is a transformation around a fixed point. Each point of the original figure and its image are the same distance from the center of rotation. So the center of rotation here is when we're talking about the origin. Okay. Now, all the rotations and the rules that we have are shown clockwise. Okay. So if we want to rotate it clockwise. Now, here's something you have to remember. If I rotate something 180 degrees clockwise, that is exactly the same as if I rotate that 180 degrees counterclockwise. If I rotate something 90 degrees clockwise, that is the same as 270 degrees counterclockwise. If I rotate something 270 degrees clockwise, that's the same as 90 degrees counterclockwise. So the rules are the same for 90 degrees clockwise and 270 counterclockwise. And again, if I'm making a note card, I'm writing that down. 180 degrees, same for both. Or same both if you're me and don't write the word for. 270 degrees clockwise is the same as 90 degrees counterclockwise, because you end up in the same position. You know, there's only so many positions you can be through counterclockwise. Okay, so here's our rules. Okay, so for a 90 degrees clockwise rotation or a 270 degree counterclockwise rotation, we take x, y, and we interchange y and x. So whatever was in the x position now is in, or whatever was in the y position now is in the x position, and we flip-flop them and we make the x negative. For the 180 degree rotation in either direction, we just make both of them negative. For the 270 clockwise or the 90 degree counterclockwise, we again interchange the x and y, we flip-flop their positions, and then we make the y negative instead of the x. Okay, so these are going to be figures that will be rotated about the origin. So again, when we talked about a center of rotation as a vertex, we talked about putting our pencil there and moving our paper around. So for example, if I was going to rotate around vertex A, I'd put my finger there and we'd move around A. Well, now when we talk about rotating around the origin, it's like I'm putting my finger in the origin and I'm rotating the figure around that way. So let's go ahead and try some of these. Here's example 2. Triangle DEF has those vertices. Graph the figure and its image after a clockwise rotation of 90 degrees about the origin. Then give the coordinates of the vertices for triangle D prime, E prime, and F prime. So start by graphing just like always. Negative 4, 4 is D. E is negative 1, 2. E, and then F is negative 1, 2, 3, 1. So here is my triangle. Now, like I said, what I like about the rotations around the origin is it's much less abstract. I don't need to visualize how this is going to rotate. It might help me to check my answer, to think about, okay, I'm going to take this whole graph and I'm going to turn it 90 degrees clockwise. So I'm going to turn it a quarter turn this way. Okay, so it's helped me to understand that I'm going to have my figure over here. But I actually have a rule that will help me find my coordinates. So again, I'm going to write up here my transformation notation. For a 90 degree clockwise rotation, the rule is I interchange and make the x negative, or change the sign of the x coordinate. Okay, so I start by listing my vertices. Oops. Let me start over. D is negative 4, 4. E is negative 1, 2. F is negative 3, comma 1. So now take it slow until you get the hang of this. D prime becomes, this is my y coordinate. Okay, this is my y coordinate, 4. That is now my x coordinate. This was my x coordinate. This is now my y coordinate, and it's negative. So I have to flip the sign. It is negative now. Okay, so I change the sign to a positive 4. Okay. E prime. This is my y coordinate. There it is. Now it turns into my x coordinate. Okay. So This would be 2. Again, here is my x. Okay, I put it in as my y and I change the sign. So this would be 2 comma 1. And f prime, this is my y coordinate. It now becomes my x coordinate. This was my x coordinate. It now becomes my y coordinate, and I have to change the sign. So instead of -3, I have +3. So these are going to be the vertices of my image. Okay, my image. And again, just a reminder, what you call it when you start is the pre-image. Pre-image to image. So let's graph it and see how it looks. Okay, again, I can visualize, I know I'm going to rotate this whole thing, so it's going to be somewhere over in here. The orientation, however, is going to be a little bit hard to visualize. So that's why we have a rule. So D prime is 4 comma 4. 1, 2, 3, 4. 1, 2, 3, 4. D prime. E prime is 2 comma 1. And F prime is 1 comma 3. 1. F prime. Okay, so this, I'll just freehand it, is my new triangle. So again, after you see the result, you can kind of tell that it's been turned that way. Okay, it's been picked up and turned that way around the origin. But for you to kind of visualize that and figure it out on your own, I think is going to be nearly impossible. You need to understand these transformations, and you need to understand how to apply them and how to do them. So that's very, very important. Again, I'd write them down on a note card so you have them ready for the test. Go ahead and try B on your own, and I will be back to go through it with you in a minute. Okay, you should be back from trying this one on your own. Let's go through it. M is 2 comma 5. 1, 2, 1, 2, 3, 4, 5. M. N is 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. P is 6 comma 1. 3, 4, 5, 6. Yeah, it is 6, 1. P and Q is 2 comma 1. Right there. M N P Q. Okay. Use my ruler so it looks nice. Okay, so now it says we want to graph the image, or graph the figure and its image after a counterclockwise rotation of 270. So again, if you look back at this box, all of these rotations we said were for clockwise rotations. So we don't have any rules for a counterclockwise rotation, except we said a 270 counterclockwise rotation. Well, that's going to be the same as a 90-degree clockwise rotation. If I turn 3/4 of the way to the left, that's the same as taking a quarter turn to the right. Okay, so we use the 90-degree clockwise rotation rule, which was the same as the one we just got done doing. So I have x comma y. That's going to turn into y comma negative x. Okay. So again, list your vertices out. M is 2 comma 5. N is 6 comma 4. P is 6 comma 1. And Q is 2 comma 1. Yes, you need to do this, and you better believe I'm not going to accept your homework if you don't. Okay, I need to see this. You're not going to be able to visualize a rotation around the origin. You just can't. Okay, I'm sure somewhere somebody can, but I would be extremely doubtful that it's you. Okay, so write out the rule, write them all out, keep it organized so you get the problem right. You want to cut corners, and you're going to lose numbers, you're going to do it the wrong way, and you're going to get answers wrong. Okay, so just do it the right way. I know it's a little bit of work, it's a little bit of writing, but that's what it takes to get the right answer. So here, 5 was my y coordinate. Now 5 is going to be my x coordinate. 2 was my x coordinate. Now that's going to be, I got to change the sign so it's positive, so it goes negative, and I put it in the y's position. N prime, 4 was my y, so now 4 is my x. 6 was my x, and it was positive, so it becomes negative. P prime, 1 was the y, so now 1 is in the x spot. 6 is the x, so I got to turn it negative. And Q prime, 1 was the y, so now 1 is the x, and 2 was the x, so now it goes negative. And there you have it. So these are going to be my coordinates of my image. These are the coordinates of my image. So now all I got to do is graph them. Okay, no visualization necessary. Now I encourage you to visualize it because it can definitely help you put it in the right position. 270 counterclockwise, 1, 2, 3 quarters of the way, or 90-degree clockwise. It can make sure it's a good check to make sure you're putting it in the right spot. If you get all your coordinates to be over here, pretty good indication that you're not doing it correctly. But in terms of actually getting the specific points, use the transformation. So m prime is 5, negative 2. 1, 2, 3, 4, 5. 1, 2. That's m prime. N prime is 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Oops, not m. N prime. P prime is 1, negative 6. And Q prime is 1, negative 2. So this is my rotated figure after a 270-degree counterclockwise rotation, which of course we now realize is the same as a 90-degree clockwise rotation. If you're having trouble understanding that, please come and see me. I can put you through some stuff and help explain it to you a little bit better in person. So that should be your answer for part B. There you have it. That's the work I expect. So here is the assignment. Red, yellow, green. The choice is yours. Do which one is appropriate for you. If you're going through and you're doing well, challenge yourself with the green. If you struggle a little bit, do the yellow. If you're struggling a lot, do the red. Thank you, and as always, have a great day.